Ever wondered how the DevOps lifecycle works? Well, you're about to find out. DevOps, a portmanteau of development and operations, is a set of practices that automates and integrates the processes between software development and IT teams. It's one of the key elements that drive the tech industry, allowing for faster, more efficient software lifecycle management. At its core, the DevOps lifecycle revolves around continuous development, continuous integration, continuous testing, continuous deployment, and continuous monitoring. It's a cycle of perpetual improvement and growth, with each stage interacting with the others in a seamless, interconnected loop. DevOps isn't merely a methodology or a tool to be implemented, it's a cultural shift, a movement that bridges the gap between development, quality assurance, and IT operations. It's about breaking down silos and fostering a collaborative environment where teams can rapidly deliver reliable, high-quality software. Now let's dive deeper into the DevOps lifecycle and its stages. First off, we have deployment. Now, deployment is essentially the process of making software available for use. It's a critical phase in the DevOps lifecycle where all the planning, coding, and testing finally come to fruition. Think of it as the bridge that connects the developer's work to the end users. It's all about delivering software that not only functions correctly, but is also reliable and efficient. There are different types of deployments, each with its own unique set of advantages. We have blue-green deployments, canary releases, and rolling updates to name a few. Blue-green deployments minimize downtime and risk by running two identical production environments. Canary releases, on the other hand, roll out the changes to a small subset of users before making it available to everyone. And rolling updates gradually replace instances of the older version with the new one. Deployment is the stepping stone to the next stage of the DevOps lifecycle. Next, we move on to ReplicaSets and Pods. Pods, in the realm of Kubernetes, are the smallest deployable units of computing that you can create and manage. A pod encapsulates an application's container, storage resources, and options that govern how the container should run. Now imagine a scenario where we need multiple instances of these pods. That's where replica sets come in. Replica sets are a Kubernetes object that ensures a specified number of pod replicas are running at any given time. In simpler terms, they maintain a stable set of replica pods running at any given time. The primary purpose of a replica set is to maintain availability and redundancy of pods, which are crucial aspects in the DevOps lifecycle. So, whether it's handling increased user traffic or recovering from pod failures, replica sets and pods work together, ensuring that your application is always up and running. Now let's talk about containerization. Containerization, in the simplest terms, is the process of encapsulating an application and its dependencies into a container. It's like packing your application into a shipping container with everything it needs to run. Tools like Docker and Podman play a crucial role in this process. Docker, an open-source platform, has been a game-changer in the world of software development. It allows developers to package an application with all its dependencies into a standardized unit for software development. Docker containers are lightweight, standalone, and executable software packages that include everything needed to run an application. On the other hand, we have Podman. Podman is a daemonless container engine for developing, managing, and running Open Container Initiative (OCI) containers and container images on your Linux system. It offers a more secure option because it does not require a daemon to function, and it manages containers at the user level, which boosts its security. Both Docker and Podman offer several benefits in the DevOps lifecycle. They ensure consistency across multiple development and release cycles by creating a uniform environment. This consistency can help reduce conflicts between teams working on different parts of a project. Another advantage is isolation. Containers isolate applications from each other on a shared operating system. This approach can reduce the risk of conflicts between different applications running on the same infrastructure. Containers are also lightweight and start quickly, which makes them ideal candidates for deploying microservices, and they're portable. You can build locally, deploy to the cloud, and run anywhere. Finally, containerization supports DevOps practices, such as continuous integration and continuous deployment. With containers, you can construct a pipeline where you build, test, and deploy software rapidly, reliably, and at scale. In conclusion, Docker and Podman not only simplify the development process, but also make it more efficient by isolating applications, ensuring consistency, and supporting CI/CD practices. Containerization simplifies the development process and makes it more efficient. Integration is a crucial part of the DevOps lifecycle. It's the magic that brings all the pieces of your development process together, creating a seamless and efficient workflow. Let's zoom in a bit on 3 popular platforms: GitHub, GitBucket, and GitLab. Each of these platforms provides a unique suite of tools for managing your code base, tracking changes, and collaborating with your team. But their true power lies in their ability to integrate with the rest of your DevOps toolchain. Imagine you're working on a new feature for your application. With GitHub, GitBucket, or GitLab, you can create a new branch for your feature, work on it, and when you're ready, submit a pull request. This pull request can then be reviewed and approved by your colleagues. So far so good, right? But here's where integration comes into play. Once your pull request is approved, it can trigger an automated build process. Your code is pulled from the platform, compiled and tested. If everything checks out, it can then be deployed to a staging environment where further testing can be done. And if it passes that, it can be deployed to production. All of this can happen automatically, without any need for manual intervention. This is what we mean when we talk about integration in the context of DevOps. It's about connecting your tools and processes in a way that streamlines your workflow. It's about removing manual steps and potential bottlenecks. It's about making your development process as smooth and efficient as possible. And the best part? Integration with these platforms is usually as simple as adding a few lines of configuration to your build scripts or CI/CD pipeline. They're designed to work with a wide range of tools and services, so chances are whatever you're using in your DevOps pipeline, you can integrate it with GitHub, GitBucket, or GitLab. Integration helps in automating the software delivery process. It ensures that your code is always in a deployable state, reducing the risk of bugs and errors making it to production. And most importantly, it frees you and your team to focus on what you do best, building great software. Let's move on to Kubernetes and Clustering. Kubernetes, often abbreviated as K8s, is an open-source system that automates the deployment, scaling, and management of containerized applications. It groups containers into what we call pods, which are units of deployment within a cluster. A cluster, in simple terms, is a set of machines called nodes that run containerized applications managed by Kubernetes. Kubernetes works by ensuring that the state of your system matches the state that you've declared. If a container or pod goes down, Kubernetes will notice and launch another one to replace it, maintaining the desired state of your system. This is the beauty of Kubernetes. It handles the complexity of managing clusters, allowing developers to focus on building applications. Kubernetes plays a crucial role in the DevOps lifecycle, particularly in the deployment and scaling stages. It aids in load balancing, service discovery, and provides a robust platform for deploying microservices-based applications. Kubernetes ensures that your application is scalable and highly available. Security is paramount in DevOps. It ensures that all the hard work that goes into creating and maintaining your application isn't wasted due to breaches or attacks. In the DevOps lifecycle, security is not a one-time event but an ongoing process. It starts from the initial design phase and extends all the way to deployment and beyond. To measure security, we use tools and practices like automated testing, continuous integration, and continuous monitoring. These help identify vulnerabilities early and mitigate them promptly. It's like having a vigilant guard continuously watching over your application. Now let's talk about secure deployment. It's not just about pushing code into production. It involves ensuring that the code is secure, the environment it's being deployed into is secure, and the process of deployment itself is secure. This includes practices like access control, encryption, and secure configurations. Security measures ensure your application is safe and ready for deployment. We've covered a lot about the DevOps lifecycle today. We started with understanding the basic concept of DevOps, followed by the deployment process. We then moved on to discussing ReplicaSets and Pods, integral elements of the Kubernetes ecosystem. Containerization, a pivotal point in our discussion, was highlighted with the help of Docker and Podman, illustrating how they streamline the creation and deployment of applications. Integration with platforms like GitHub, GitBucket, and GitLab was our next stop, showcasing how they facilitate collaborative programming and version control. We then delved into the world of Kubernetes and clustering, explaining how it helps manage containerized applications. Finally, we examined the importance of security measures in the deployment process, emphasizing the need for vigilance and continuous monitoring. This was just a brief journey into the vast landscape of programming. Don't forget to like, comment, and share if you found this video useful. Stay tuned for more insights into the world of programming.